So let us begin. Today we will be talking about number systems. Am I properly audible, or is there any problem? Properly audible? Yes, students, am I properly audible?
Yes, sir.
Okay, fine. So now let us begin. So today we will be talking about the number systems. In digital electronics, as I already discussed with you, that it is either it is 0 or 1. So we actually first need to understand what do we actually mean by binary numbers, how we can convert from our conventional decimal number system to the binary number system, and what is the role of binary number system in those digital circuits. So we shall one by one be discussing this idea of the number systems. And if we uh, go to our conventional decimal number system, I mean the number system which most of us use in our day-to-day life is actually the decimal number system. Digits, we also call them digits. And in decimal number system, we have 10 digits, like say 10 symbols, like which are used to represent the digits. And these are 1, 0, 1, 2, 3, 4, 5, 6, so on, and 10. Fine. And in any number system, we call this number of symbols or number of different symbols in a number system as radix or base. So our conventional, this decimal number system has a base 10, or radix we call it as. The radix of our conventional number system is 10. The meaning of this or usage of this will be clear shortly. Now, any number system arranged in some specific order, and that is what representing a number in what we so that is why I'm quickly just defining these things for you. So in any number in decimal number system, we have this part which is before this decimal, we call this decimal. So this part is what we call integer part. So this part is integer part of the decimal number system. So in this case, the integer part is 1263, correct? And this part is called, yes, anyone from the audience, what is this part called? Oh, too much lag in audio. Uh, are you able to hear me now?
So we cannot be listen you properly.
I hope I'm audible there.
सर लैग कर रहा है काफी ज्यादा.
This is called fractional part. So we have two components in any number. One is integer part, and other part is fractional part. And this part in the middle is what we call radix point. Remember, radix in general, this is 10 in case of decimal number system. So that is why we say this as decimal point as well. So usually in any number system, we have three components. whenever we are describing a number system. One is its integer part, other is its fractional part, and we have something called radix point in between. Okay, fine. Just as we have a decimal number system, which has a collection of 10 symbols to represent any number, we may also have other number systems as well. It's not mandatory that you should just follow the decimal number system. Or whosoever invented this number system could equally well have invented some other number system. Why only 10 symbols, right? So we may have got something like only say two symbols, and in case we are using such a number system, that is called the binary number system. Binary means only two components. So in case we have number system, octal number system, we don't have 8 and 9. So in case you have to represent 8, in case you have to represent 8 in octal number system, we can't use it like directly like 8. So how we do things in octal number system shall be shortly clear. So let us not get into that directly as such now. But okay, we have a binary number system which is made up of two distinct symbols, 0 and 1. Octal number system which is made up of 8 distinct symbols. We may equally well have a hexadecimal number system which contains 16 symbols. Now in decimal number system, we are familiar with 0, 1, 2, 3, 4, 5, 6, 7 all the way up to 9. But what if we have to choose 16 different symbols? So in hexadecimal, as the name indicates, hexa means 6, decimal means 10. So this has 6 and 10, 16 different symbols. And these 16 different symbols are used to represent a number. So the base for a binary number system, what is the base or radix for a binary number system? 2. What is the base for a decimal number system? 10. What is the base for a octal number system? It is 8. What is the base for hexadecimal number system? It is 16. Your screen is not visible. What happened now? Don't do all these presentation. Is it visible now? Mukal recently joined and maybe he did some left and right. So join simply and sit in the meeting. That's all. Is it visible now?
Yes, sir.
So please don't do all those random experiments with the screen. Okay, just simply listen and try to see what is being told. Okay, so I hope you were able to get this binary, what is binary number system, octal or hexadecimal number system. So the base in case of a binary number system is 2, base for octal number system is 8, and base for hexadecimal number system is 16. Did you get the idea? Okay, fine. So now, okay, don't be confused. This that okay, what we are doing here, the things will be clear in not one single lecture, but maybe coming to 3 lectures. So today we will in detail talk about binary number system. Then when we will be discussing other number systems, things will be clear. For now, you just remember that okay, what is the number of different distinct symbols in each number system? Now, okay, let us take a general case where suppose the base of any number system is B. Let us assume that base for any number system is B. For example, for decimal number system, B is 10. For a binary number system, B is 2. For an octal number system, B is 8. For a hexadecimal number system, B is 16. So in general, any number in any number system can be represented by this general notation, as I already described here for a decimal number system. So we have an integer part, as we already discussed here, as an example. And so on. These are called digits. These are called digits of the number system. And in case of binary number system, these are also called bits. So we can have 0 and 1. This is called a bit, right? So fine. So this, remember, this is going all the way up to n, correct? So this is going all the way up to n means, okay, so here capital N means the number as such. B is here, B here is the radix or base of the number system. And this small n and small m. Try to see now integer part. So this digits are going from 0, 1, then there would be 2, 3, so on, all the way up to n minus 1. So how many digits are there in the integer part? How many digits are there in the integer part? Okay, Anshul is asking for hexadecimal. Okay, I'll be talking about this. Let us first come to this part. So how many integers are here? N. So we have total n digits in the integer part. 1, 2, 3, 4. For example, what is n here in this example? N is 1, 2, 3, 4. N here is 4. So accordingly, you can say, okay, how many digits are there in the integer part of the particular number? It's not n minus 1, Tushar, it is n, isn't it? Because it is beginning from 0. So 1 is going for 0, then 1 means 2 digits. If we have D0 and D1, we have 2 digits. So all the way up to n minus 1, we have total number of digits as n minus 1 and 1 corresponding to D0, which is giving us total n digits. Correct? Okay. And here, m represents the number of digits in the fractional part. So for example, here we have total digits like d minus 1, 2, 3, 4, and so on up to m. So total here are m because we are already beginning from 1. Now you may ask, okay, why is it minus 1? We will be talking about this. It is something like place value. We will be talking about this shortly. In And what does this mean here? Dn minus 1. So this leftmost digit in the integer part is called most significant digit, MSD. For example, here, what is the most significant value for 6? It is tens. So 6 is sitting 1000. Part is called least significant digit, LSD. Various Yes, other students, can you hear me? Yes, your response, please. I'm not able to see any response. Am I audible to all of you? What can be done in that case? I don't know. Anyone else who can hear me properly? Shubh Thakur. शुभ, आकृति, दिया. Yes, can you all can you hear? Can you anyone hear me? Please unmute your mic and just let me know what you are not able to get. Can you hear? Unmute your mic. Arati Sharma. Yes, who is talking? There is some problem or what? Students, do respond properly. I'm not able to get your responses, so I don't know whether I'm still online there or not. I don't think there should be any problem.
सर आप ऑनलाइन हो बट आपकी आवाज़ कई बार लैग कर रही है बीच में. आई थिंक मे बी बिकॉज
कितना
ऑफ
लैग कर रही
नेटवर्क प्रॉब्लम है सर.
कितना लैग कर रही है? अभी आप सुन पा रहे हो मुझे लाइव या नहीं?
10 सेकेंड्स या 20 सेकेंड्स तक लैग कर रही है बीच में कई बार.
कितना लैग कर रही है मतलब समझ आ पा रहा है उसमें कि नहीं?
नो सर.
नहीं आ रहा है?
नो सर, बीच में छूट जा रहा है ना तो समझ नहीं आ रहा फिर.
सर
Okay.
बाइनरी से हेक्साडेसिमल पहुंच जा रहे हैं हम सही.
What is the problem then? एक सेकंड रुको. Okay, hello. Am I audible now? Is there some improvement?
Yes, sir.
Yes, sir.
Okay, I changed my network. Maybe it will be better now. Can you see the screen or I need to share the screen again? Is it visible? Presentation?
No, sir.
नो सर.
No? Okay, so I hope it should be visible now. Is it visible?
Yes, sir.
यस सर.
All right. So we were talking. Okay, now I want you to ask question. I don't know what all you got and what all you missed. So what all did you miss? Please ask me questions so that I can accordingly re-explain things. Yes, your questions, please. most significant and least significant number. Repeat. Okay. MSD, LSD. Anything else? Yes. Any other thing? Any other question? Okay. Fine. So NB से कुछ नहीं लगा पता. Either write English or write Hindi. I can't understand it properly. You should write one particular language. Anyway, you didn't get what is NB. Fine. What else? MSD. Okay, let me re-explain or retry this thing. So I hope you got this idea. What is the number system and what is integer part and fractional part? What is radix point? This I hope is clear. And then accordingly we have other number systems as well. So this is typically is representing a decimal number system and representing like 1263.579. Similarly, you may have other number systems where we have only suppose two symbols, and that is what we call the binary number system. And the base for a binary number system shall be 2. What is base? It is number of different digits or number of different symbols in a number system. So in a decimal number system, we have 10 different symbols, 0, 1, 2, 3, all the way up to 9. So in binary number system, we have only two symbols, 0 and 1. So that is why the base or radix for binary number system will be 2. Similarly, you may have an octal number system where the base will be 8. Like the symbols are 0, 1, 2, 3, all the way up to 7. Similarly, you may have hexadecimal number system for which the symbols will be 0, 1, 2, 3, and so on up to 9. And then this defines 10 symbols. Then you have to define 6 other symbols which are taken from alphabets like A, B, C, D, E, F. This represents the symbols for hexadecimal number system. So the base for hexadecimal number system will be 16. Fine. So in general, this NB, suppose we have a number in any number system. So how we can represent a number in any number system to a base B. So say for example, in this case, B will be 10 for a decimal number system, B will be 2 for binary number system, B will be 8 for octal number system, and B will be 16 for hexadecimal number system. Now, we have an integer part, right? So this represents, B represents the base of the number system, as I already told. N here is representing number of digits in the integer part. So in this integer part, what are total number of digits? They are from 0, 1, 2, 3, so on up to n minus 1. So total n digits are there in the decimal number system. For example, here, what is the number of digits in the integer part? They are 4. 1, 2, 3, 4 digits in the integer part. Similarly, M represents the number of digits in the fractional portion. So in this case, or in this example, we have 3 digits in the fractional portion or fractional part of the given number. Similarly, Dn minus 1. So if you take here, we are going from D0, D1, D2, D3, D4, so on up to Dn minus 1. So the most significant digit in this case is Dn minus 1. That's what we are saying here. In this example, what is the most significant digit? 1, because this is sitting at 1000th place. What is the place value for 1 is 1000. So this is the most significant digit, as you must have done in your elementary classes. Similarly, there is something called least significant digit. What is the least significant digit? Is 9 here, right? So this D minus M is called least significant digit. So the digit which is rightmost in this number is least significant, and the digit in the leftmost side is called the most significant digit. Is this clear now, or is there still some question? Okay, fine. So this is very simple. Fine. Now, next, let us come. Okay, fine. There is one more thing, that number of digits or we shouldn't say number of digits, but the values of digits. Like, okay, di or whatever digit, how many values of digits a digit can assume? A digit can take maximum b values. B is the base, right? So for a decimal number system, b was 10. So what are the possible values of for any digit? It can be any 10 values. So for example, here a digit can be 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. So in a decimal number system, the value of digit can be all the way from 0 to 9. And for a binary number system, the values a digit can assume is only 0 or 1. So in that case, 0 will be less than equal to di is less than equal to 1 for a binary number system. Similarly, for octal number system, there are 8 possibilities or 8 different values any digit can assume. That's the meaning of this particular line. Fine. Now let us talk some more examples related to these number systems. So digits in a number are placed side by side, and each position in the number is assigned a weight or index of importance by some pre-designed rule. Okay, fine. What is the meaning of this? That okay, this is the what I can say, the example table which will demonstrate all the things which we talked. So in binary number system, what is base? It is 2. What are symbols? 0 and 1. This is just summary of what we already did. Weight assigned to the position. So suppose here I is representing ith position. So suppose this is the number here. So let us start with let us discuss the decimal case first, because it should be easiest to understand. So in decimal number system, what is the base or radix? It is 10. How many symbols? There are total 10 choices. Now the value or weight assigned to each digit is 10 raised to the power I. And this is for the case of integer part. So what is the integer part? Anything to the left hand side of the radix point is integer part, and anything to the right hand side of the radix point is the fractional part. So in decimal number system, what is the meaning of this 10 raised to the power I? So if I take 4, it is sitting at what place? 0th place. Why 0th place? Let us come to this case. Okay. So this is radix point. This is what we are saying. This is these subscript here, D0, D1, D2, D3 is actually representing value of I. So first digit is D0, means I is equal to 0 for this, I is equal to 1 for second, and so on. So this is representing the value, right? Or the location of the digit in the number. So here 4 is sitting at I is equal to 0. So what is the weight assigned to 4 is 10 raised to the power 0, 1. That is what we call units place. I hope now you are able to relate the things which you have done in the elementary class. Then where is your 7 sitting? 7 is sitting at I is equal to 1. So what is the place for, or what is the weight assigned for 7? It is 10. 10 raised to the power I is equal to 1 here. So it is 10. So place for, or the weight for 7 is 10. Means 7 is sitting at 10's place. Units place, 10's place. Where is 9 sitting? For I equal to 2. So I is equal to 2 means 100. Means 10 raised to the power 2 means 100. So 9 is sitting at 100th place. 3 is sitting at 1000th place, and so on. Similarly, if you talk about 5, so 5, if you say now 5, this is the weight for the fractional part. So f is equal to 1. If you come here again, let me, okay, go back to the previous one. Yeah. If you come here, this is representing the value of f, like -1, -2, -3, and so on in general, minus f. So in this case, what is this saying? Okay, f is equal to 1 for 5. So what is the weight for 5? This is 1 by 10. Means the weight for 5 is 0.1. And what is the weight for 7? This is 1 by 10 raised to the power 2, right? Means 10 to minus 2 it is. So it is 1 by 10 raised to the power 2. So the weight for this is 100. 1 by 100. Is it clear? Is it clear? Is the place clear? Where is Subhash? Yes, Subhash. Why you were calling me? Unmute your mic. Now let us talk.
सर मेरा ज्वाइन नहीं हो रहा था तब से.
क्यों? पहले तो आप ज्वाइन
सर ज्वाइन नहीं हो रहा था तब से ज्वाइन कर रहा था पर मीटिंग में आ नहीं रहा था.
You every day face some problem, and then in the middle of the class you start calling. So you shouldn't disturb the middle of the class.
जस्ट सर 10 मिनट से ट्राई कर रहा हूँ, मतलब हो ही नहीं रहा था.
बाकियों का तो हो गया, तुम्हारा क्यों नहीं हो रहा था? आप लेट आते हो क्लास में तो फिर ज्वाइन कैसे होगा? मैं क्योंकि क्लास ले रहा होता हूँ. Then I don't see your request trying to join it. 10 मिनट से आप कर रहे हो. It is already 12:38 now. हाँ? चलो anyway, I mean टाइम से ज्वाइन किया करो और in between आप कॉल वॉल करके डिस्टर्ब ना करें. टाइमली ज्वाइन करोगे. शुरू के 5 मिनट में आप लोगों को क्लास ज्वाइन करने के लिए देता हूँ. Then you should join. और उस दौरान ज्वाइन नहीं हो रहा है, you should give me a call. In between class, it doesn't sound good. I mean, it just stops the whole flow of the class. So शुरू के 5 मिनट में किसी का ज्वाइन नहीं हो रहा है, you can call me. Fine. Okay, so did you get this idea of weight of a particular digit in a number? Is it clear? So we discussed the significance of weight for a decimal number system. Now, how to understand weight for a binary number system? Now, for a binary number system, the base is 2. Now, see, for decimal number system, the base was 10. So that is why we were taking 10 raised to the power I or 10 raised to the power minus f for integer and fractional part respectively. For a binary number system, we have the base 2. So that is why weight for each digit or each bit will be 2 raised to the power I. So let us take this example. So here, what is the weight for this first number? It is 2 raised to the power 0. Is it clear? Then second is 1 here. So it has a weight 2 raised to the power 1. Third is 0. So what is the weight here is 2 raised to the power 2. So the weight for first digit here is 1. The weight for second digit is 2. Isn't it? 2 raised to the power 1 is 2. Weight for third digit is 4. Weight for this digit is 8. So weights are like 1, 2, 4 and 8. That is how we define weight for binary number system. Yes, any query? I'm hearing some voices. Is there any doubt from what I just talked? Yes, anyone from audience? Is it clear? Anika Chaudhary. All right, so let's move to the next thing. So binary, I assume that this is clear now. You will get more familiar when you will discuss the numbers themselves. So in octal number system, accordingly is the weight, and similarly for hexadecimal system, that is how we assign the weight. Let us consider an example now. Suppose we have a number in general in any number system, which is having 1, 2, 3, 4 digits in the what you can call integer part, and you have 3 digits in the fractional part. Please note here carefully that, okay, I have not written it as a D0, D1, D2, D3 or digits before integer part, but okay, you should assume the weight for this is say whatever is the base raised to the power 0. For this digit D5, the weight is base raised to the power 1. For this digit D6, the weight is base raised to the power 2, and so on. Similarly, for digit D3, the weight is base raised to the power -1. For digit D2, the weight is base raised to the power -2, and so on. Correct? So I hope that is what I already represented. Fine. So how we can write down the number? This number, if the base is b, then the value of this number will be d7 into b raised to the power 4, d6 into b raised to the power 3, and so on. Let us take it for the case of this decimal number system. Say 3974.57, right? How we write this number as itself is like 3 into 10 raised to the power what? 3, right? What is the weight for 3 is 10 raised to the power 3, correct? What is then plus 9 into, what is the weight for 9? 10 raised to the power 2. So accordingly, 9 into 10 raised to the power 2 plus 7 into 10 raised to the power 1 plus 4 into 10 raised to the power 0 plus 5 into 10 raised to the power minus 1 plus 7 into 10 raised to the power minus 2. So that is how we can get a full number out of different digits appearing in the number in terms of their weights. I mean, in terms of the position where the digits of the number are appearing. Is this clear how we got this number? How we can get a number from its weights? Fine. So in general, how we can write down a number? So n is equal to summation over I goes from minus m to capital N. Now those m and n have the meaning which I have discussed in the previous slide, correct? And this is how we can write down summation over di, the value of the digit at ith position, times the weight. So b raised to the power I is defining the weight of that particular digit. This you have done in your elementary classes. All those small place value questions are already discussed. So that is fine. Now let us first try to understand a binary number system. Then we will be discussing all other number systems one by one, and also interconversion of the various number systems. So first let us talk about the binary number system in detail. So as I already told you even in the previous slide, that binary number system is the number system which has only two symbols, 0 and 1. That is why it is called binary number system. And what is the base for binary number system is 2. B for binary number system is 2. And as we call digits in any number system, so here we can call those digits as bits. And that is where the concept of bits, byte, megabyte, gigabyte, kilobyte, etc. comes into picture. So we will be discussing all that in the coming classes. So one digit in the binary number system is called a bit. You should note it carefully. And this system has a minimum base. Now this statement is something really interesting. We are saying that, okay, this binary number system is the number system with the minimum base. Why so? Because we can't have any number system with the base lower than 2. Because if the base is say 1, that is not at all useful. How? Because if I have to write down say 0, then I have to write down it with, there will be only one single symbol. Let us say the symbol is A. Then if you have to write down 0, it will be like A. And if I have to write down say 1, it will be AA, isn't it? Because there is no other choice. If you have to write down 3, then it will be like AAA. This is simply like, okay, counting with the help of placing the objects, which doesn't make sense. And the base is 0 means we can't at all define any number system. So binary number system is the number system with minimum base or the smallest base. So and this is a positional system, means every position is assigned a specific weight. So that I already told that what is the meaning of weight in a particular digit appearing at a specific position. Okay, Abhi is asking a question. D4 into B0, B raised to the power 0. Okay, let me go to the previous slide, what you're trying to say. D4, yes, D4 into, it should be D4 into B raised to the power 0. Indeed, D5 into B raised to the power 1. So I have done a mistake here. very nicely pointed out by Abhi Kashyap. So in this example, it should begin from b raised to the power 0. Then it should be b raised to the power 1, because weight for d5 is b raised to the power 1, correct? And weight for d6 is b raised to the power 2, and weight for d7 is b raised to the power 3. Very correctly pointed by Abhi Kashyap. I think others should also be concerned what I have written on the screen and be careful. Fine, thank you for pointing this out. Well, so fine, we talked that, okay, each position has a specific weight. So here is some example of the binary numbers and corresponding decimal equivalent. So, you know, when you write down counting in decimal number system, how we used to do, first of all, we start with 0, isn't it? Smallest number is 0. Let's not get into negatives. So we start from 0, then we go to 1, 2, 3, 4, 6, 7, 8, 9. So up to 9, we can survive with the single digit, right? Even if we don't write this D1 values, that doesn't make any difference. I mean, up to first 10 numbers in a decimal number system can be written with a single digit. Now to write down 10, we can't afford to write it within single digit, right? Now we have to use combination of the digits. And that is how we do counting, I mean, write counting. So what we do is, okay, we initialize this digit. So, okay, it is something like, okay, this digit is going from smallest to higher and higher and higher and higher value. Here it is at highest value. 9 is the highest value any digit can assume. Now what we do is we reset this digit to 0. So we are going again back to the smallest value of this digit. And on the cost of this resetting, we increment next digit by 1. So we write like 1 0 means 10, 1 1 means 11, 1 2 means 12, and so on. And then when you ultimately hit at 1 9, what you should get is, okay, now again this smallest or least significant digit is highest. Now we can't go beyond 9 as such. So we have to reset 9 and increment next digit. So it will be 2 0, 2 1, 2 3, and so on. So that is how we write down counting or numbers in a number system or number sequence in a number system. In case of a binary number system, we have only 2 digits. How can we write down 0? Just like, okay, simply 0. How can we write down 1? That's simply like 1. Now to write down 2, we don't have a new symbol, right? We have only 2 symbols in binary number system. The base is 2. So how to write down 2 is like 1 0. I mean, we initialize this least significant digit and increment the most significant digit by 1. It's not most significant digit, but the next to the least significant digit, we will increment that by 1. So this is 2 here. 2 can be written in binary number system by 1 0. And then how we can do, this is 1. Next will be, what is the choice? Least significant digit is to be incremented. So we write down 1 1 representing 5. Now again, this digit has reached its highest value 1. Now we have to initialize this. Fine, this will be 0. And then this one, B1, if you refer to this column, B1 also has to be incremented. But this already also has attained its highest value. So this also has to be reset to 0. That's what we did here. Now, if this is 0, or if this is reset, what will happen? One carry will be forwarded to the next bit. So all this bit, this B2 will be 0 up to this point, then it will be incremented. Now what will happen for next number? So I mean something like 5, okay, this is 5. 5 will be written like 1 0 1. Then 6 will be like, okay, now this is reset, this is incremented, and so on. I'm sure you got the logic. How can we write down counting in binary number system? So that is how we can write down number count or number sequence in the binary number system. Is this idea of writing number sequence in binary number system okay? 100 means which 100 now? Rohit, Mohit. What do you mean by 100? I mean, are you talking of a binary 100 or decimal 100? decimal 100. So I will be teaching you conversion of any number. You can write down 100, 1000 or whatever number. We are coming to this in the next slide. Fine. So interestingly, this 100 in binary number system would be what? Yes, can all of you do a quick calculation? At 6, 7, B2 and B3 are same. What are you saying, man? I didn't get. 6, 7, B2, B3 are same. I didn't get. 100 is 4. Fine. What is Subhash trying to say? I didn't get your question. What you're trying to say? Subhash. Okay, fine. 4. Stop. That's sufficient. You knew the answer. Fine. Oh, I didn't take your attendance, right? What you do is you write down your roll numbers as well as a part of your attendance, your respective roll numbers. Okay, fine. So let us come here. So that is how we can write down the numbers in the binary numbers. Now, this is the job which we want to do. Now, how can we convert any binary number to corresponding decimal number? Let us take this example. Now, okay, how we write down a number? In brackets, this is the convention we follow. In brackets, we write down the integer, all the digits of the number, and then the base is written as a subscript outside the bracket. So 11111 written with the 2 at the base is representing a number 11111 in the binary number system. If we would have written 10 here, that would mean 1111 in decimal number system. So 2 are totally different. And if it would be like, okay, base is 8 here, so that would represent the number in octal number system. Okay, so since we are talking of binary number system, let us stick to the binary number system. Now, can we really convert this number to corresponding decimal equivalent? How we get? What is the weight for each digit? So this one has a weight 1. This has a weight 2 raised to the power 1. That is 2. This has a weight 2 raised to power 2. That is 4, and so on. What will this number be equal to? Yes, do a quick calculation in your notebook. Okay, Parikshit came up with the answer. It is 31. Okay, I could see your single sentence as well. Abhi, 31. Is everyone getting 31? Don't just copy and paste from others. Just paste your answer. If it is wrong, it will be wrong for all. Okay, Jyoti is saying 30. Very good. So, I mean, you should have your own answer. It can be wrong. That's okay, no problem. Okay, most of you are finding 31. Let us see what is the answer. So, this is how to convert it. Correct? So, I mean, what is the weight for this? 1, begin from here, say 1 into 2 raised to power 0 plus 1 into 2 raised to power 1 plus 1 into 2 raised to power 2 plus 1 into 2 raised to 3 plus 1 into 2 raised to power 4. So, what is this total? This is 31 to the base 10. Very good to all of you. I mean, who did it correct, who missed it, please note the logic. It's very simple. Let us try to come to this number now. Yes, solve it and let me know the answer. What is this number equal to? What is its decimal number? So here you have to be careful. You have to get an integer part and you have to also get a fractional part. And you know the weightage for fractional part, it is going to be 2 raised to the power minus 1, 2 raised to the power minus 2, 2 raised to the power minus 3, and so on. Yes, please get the answer and then tell me the answer. Yes, take your time. I am just holding for a moment. Till then, you just do the calculation and let me know what is the number. I hope you all are sitting with your notebook. So you must have a notebook with you. Yes, any answer, please? $45.25. Parikshit got it as a 45.25. Yes, others, please. Yes, I'm giving you time. Yes, take your time and get it done. Yes, any other student with answer? Are you calculating? I hope you all are. Subhash, doing calculation or not? Subhash. Okay. Yes. Mohit. All should switch on your camera. I should see your notebooks. Switch on your camera and place your notebook in front of your camera. All of you. I want to see you with your notebooks so that I got to know that you're not sleeping. Place your notebook in front of your camera. Very good. Mohit, very good. I could see Mohit, Pallavi is responding, Disha, very good, Pranjal, Akriti, Subhash, Anshul. Anshul, where is your notebook? You are somewhere on highway. Okay, anyway, you have a notebook? Anshul? Anchika has a notebook, very good. So be careful next time. I mean, I think all of you are fine having notebooks. So you should have your notebooks with you. Okay. So anyone got the answer? Fine. Yes, yes, please keep trying. Get me your answer. Or okay, I mean, today's time is over. So what we can do is I leave it to you and you get it done by tomorrow. And then we will discuss it in detail. Parikshit is getting something like, oh, earlier you was getting 44, you were getting 45.25, now it is different. So you all take your own time. I leave it to you. You do it as a homework properly. Note the number which you have to calculate. And tomorrow we will discuss how we got that number. Okay? With this, we will be doing all the other things tomorrow. So how to get, how to convert other numbers. There was a long list of assignments. Okay, note these numbers as well. At least you take the first assignment, this one. You have to convert all these binary numbers to corresponding decimal equivalents. You can take a screenshot of your mobiles. That will be easy to note, or you can note in the notebook as well. So note these numbers. Tomorrow I want you to find out or come with the homework done. Find out their decimal equivalents. Noted? Yes, I hope all of you have noted it. If you have not noted, you can share it with from your friends, or even I can post this screenshot in the WhatsApp group. So fine, till then, thank you very much for your kind attention. Stay safe, stay healthy, good luck. We'll meet tomorrow as per timetable. And make sure you join the class timely so that I don't have to, get distracted while taking class. Okay, fine, thank you.